but let's talk about what we're going to do the next couple days. First of all, we're moving into conics, and conics are parabolas, circles, ellipses, and hyperbolas. The good news is this should be review, okay? So this shouldn't feel completely foreign. And the bad news is not everybody loves conics, but it is what it is.
Is it 4.6?
So this is not in your notes, okay? So that's what I was going to feed into. This is, and I would say, these are the steps for completing the square specifically for a parabola. But it's going to change as we kind of, like not the first couple steps, but the ending is going to change depending on what you're using this process for. So before we get into the notes for circles and parabolas that we'll start today, I wanted to review complete the square because it is a skill that's going to get built into all of the conics, okay? So this comes from Algebra 2. So in Algebra 2, when we complete the square for a couple different reasons. One is to solve a quadratic equation, and one is to put a conic in its standard form, okay? In all of these, they are quadratic, meaning there's an x squared, okay? So for just a parabola or a quadratic, that not like a circle or an ellipse or a hyperbola, you only have one squared term. So the goal is to, if you remember this, like let's say I'll just give you an example, and I'll make it easy, and then we'll kind of step into what we need to know. So if this said x squared plus 4x plus 7 equals 0 or equals y, for example, or f of x, it could equal whatever. And I want to put this into standard form. Then the first thing I'm going to do is group together the squared term and the non-squared term. And we leave a space. So if you don't remember, a lot of times usually when I do that, it jogs your memory, okay? That we're going to fill that space in. Sometimes we bump the 7 to the other side. Sometimes we keep it on the same side. So we're going to talk about what happens if it's in both those cases. Then if a is not a 1, we would factor the a out. So we'll do one of those in a second. But if there was something in front of the x squared, we would factor it out of both these terms. And then we would complete the square. We're going to divide b, which is the second term, by 2. So in this case, I made it nice and easy for the first time, but 4 divided by 2 is 2. Then we take that term and square it. 2 squared would be 4. Then we add it inside the parentheses. So I would add the 4 in here. And to keep the equation balanced, we have two choices. Subtract it on the same side, or add it to both sides, because you could also do that. So in this case, I'm subtracting it from the same side, so I keep this on the same side, but I also could have added 4 to both sides of the equation. Then I'm going to factor what we just made into a perfect square trinomial. So the whole goal was to make this factorable. And to do that, the shortcut is to square root the first term, square root the last term, take the sign from the middle, put it in parentheses, and square it. So if it's a perfect square trinomial, which is the goal, like to make it a perfect square trinomial, then we can use that shortcut to factor it. So if I go back up to the top, I would square root the x squared, I get x. I would square root the 4, I get 2. I take the sign from the middle, it's a positive sign, put it in the parentheses, and square it.
And you have to add 3.
Yep, then I'm going to do 7 minus 4, which is plus 3 equals y. So depending on what your goal, you may leave it like that. If I wanted to just know what, like let's say I wanted to graph this parabola, I could graph it from here, right? What would this parabola look like? What kind of translations are happening? A shift left and up 3. So if I was doing this to figure out where the vertex was or what the graph would look like, then I can leave it like that, okay? If I'm trying to get it into standard form, we'll do that when we get into parabolas. Then I move these things around, okay? But when we get to the parabola portion of the conic, which will probably be tomorrow, we'll talk about that, okay? Questions on the process? Because now we'll do it a little bit more complicated. Okay, so now let's say I had f of x equals 2x squared plus 3x minus 8. What's step 1? Group together the first two. Yeah? Actually, let's make this a negative. So we do one with a negative. We're going to change this. Make that a -3. So step 1 is group together the first two terms. Now what's happening this time that didn't happen last time? There's something on the A other than 1, right? So we got to factor it out. So when I factor out a 2, I'd get x squared, and that 2 is going to come off the 3 too. So this would be -3 halves x. I'm going to leave my space, -8. Now I got to find that third term. So I take the second term, which is 3 halves. I ignored the sign because I'm going to square it, so it will always go positive. I take that, divide it by 2, which is the same thing as multiplying by half, and I get 3/4. And then I square it, and I get 9/16.
Wait, so you have to divide by 2?
You have to divide by 2, then square. So I am adding 9/16 inside the parentheses. And normally I subtract 9/16 from outside the parentheses to balance. But because I took this 2 out, whatever you take out has to get multiplied by what you're adding or subtracting before you do it. So I'm going to multiply this by 2. So if I take something out and it's on the front, I have to multiply it by what I added inside the parentheses before I combine it with the last number. So this becomes, well, yeah, but then simplify that. So I would do -9/8. And that's going to get subtracted from the 8. So this becomes negative, I'm going to multiply by 8, 64/8 minus 9/8. And that's -73/8. With me so far? Bring down the 2. So 2. We square root the first term. Square root of x squared is x. We square root the last term, which would also be what happened over here before I squared it. 3/4. And we take the sign from the middle. This time it's a minus. Put it in parentheses and square it. So my f of x equals 2x minus 3/4 squared minus 73/8. So now describe the translations or transformations on this parabola.
Dilation.
What kind of dilation?
Or vertical.
Vertical dilation by a factor of 2. What else?
Right 3/4.
Translated to the right 3/4 and?
Down 73.
Good. And down 73/8. You with me so far? Okay, we're going to do one more.
Oh, is this like another?
Yep. Have we done a minus on the outside? Yeah. All right, step 1. Well, first group together the first 2, right? Because we don't want to factor the 3 out on the 1 yet. Then take out the -3. This time it's a negative, which means it's going to flip the sign on that 5. This is going to be -5/3. Now I got to fill in that space. So I'm going to take the 5/3, divide it by 2, which is multiplying by half. I get 5/6, and then I square it. 25/36. And I add it inside the parentheses.
Is it always addition?
Inside, yes, because you're always squaring it. So that's why we ignore this minus when we figure out what b is. Like when we divide by 2 and then square it, we ignore the minus on the 5/3. That part will inside the last c will always be positive. Yep. Now we're going to subtract it outside here. So -25/36. But before we combine it with the 1, you got to multiply it by what's on the front. So because we took out a negative and we're subtracting, it changes the signs. This becomes 3 goes into 36 twice, and a negative times a negative would be a positive. So this would be plus 25 over 12. So I'm going to combine these two. 1 becomes 12 over 12 plus 25 over 12, 37 over 12 is the end. So it's negative 3, square root the first term, which is x, square root the last term, which is over here before I squared it, but I can also just square root 25 and 36. Take the sign from the middle, put it in parentheses, squared, plus 37 twelfths. Questions? Okay, so the PDF I posted is of solving these. If we're solving these, then I'm going to set this equal to 0. I would subtract the 37 over 12, divide by negative 3, square root both sides, and add the 5, 6. They are not that messy, I would say, when we're solving, okay? And for conics, I mean, sure, could we get the zeros? Yes, but for the most part, we're learning just how to put them into standard form for now. So I gave it to you, I think I made it non-graded because I gave you the answers. You have to know if you need the practice with the complete the square or not. If you need it, do it. If you're confident in everything we talked about today, then you don't have to, okay? Because it will get built into the next 3 days, which are the next 3, like 4, 6 divided into 3 parts. We're going to sporadically do complete the square. But if you know this is something you need to work on, then make sure you know how to do it, okay? All right, so we're going to start 4, 6. So this is what the homework is. And I would not say you need to do all of those. Maybe pick one that has a leading coefficient, one that doesn't, one like that kind of stuff, okay? This is extra practice. This is 4, 6, part 1. So we divide it into 3 because it is it's 5 conics. It's circles, parabolas, no, it's 4 conics. Circles, parabolas, ellipses, and hyperbolas, okay? So in 4, 6a, we group together the circles and parabolas, and then B is ellipse, and then C is hyperbolas. So we'll try to do the circles today, and then we'll kind of pause after there. All right, so a conic is a section of the that is caused by the intersection of a plane and a double napped cone. So that double napped cone is like an hourglass shape. If I take a plane, so like even if you took like a piece of paper or something and you slid it horizontally through it, then you get a perfect circle. If you slide it at a diagonal, you get that oval shape, which is called an ellipse. If I clip off a little edge of it, I get this shape that would be the parabola. And if I slide it vertically through, I get the shape that would be the hyperbola. So that's where all of these shapes come from, and these are all called conics. And again, we will go over all 4 of these in the next 3 days. Yeah, you remember this from Algebra 2, right? Yeah. All right, so we start with a circle. A circle is the collection of all points x, y that are equidistant from a fixed point hk. The standard equation for the circle is x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. So if it had said x minus 3 squared plus y plus 2 squared equals 16, what is my center? Not negative. We switch it, right?
3, negative 2.
Center would be 3, negative 2, and my radius? 4. Good. And if I needed to graph that, I would go right 3, down 2, make my center. And then I would literally count up 4, right 4, down 4, left 4, and draw, to the best of your ability, your circle. Good so far. All right, example 1 says point 1, 4 is on a circle whose center is at negative 2, negative 3. Write the standard form of the equation of the circle. So first of all, standard form is x minus h squared plus y minus k squared equals r squared. And we typically plug in for the center and the radius. Well, we have the center, that -2, -3 is my HK. Do you have the radius? No. I have a point on the circle, right? So there's a couple different ways to do this. What's one way to do it?
You do the slope thing.
The slope thing.
Y2 over the y.
No, because that would give you the slope of the line.
But that would find the radius.
No, you're thinking distance? Distance. So the distance between the center and a point on the circle would give you the radius. Yes, that's one way. What else?
You can
How could we find the equation in the end?
You plug in 1,4 into the da-da-da.
The other way, and it would be what I recommend because people mess up the distance formula when you start square rooting and stuff, is take that coordinate point. That coordinate point is your XY. And then the center is your HK, and then you plug in. You'll have 4 things plugged in for. The only thing you won't know is your R. You'll solve for R. So X is 1. H is -2. So minus a -2 becomes +2. God bless you. Y is 4. K is -3. So this becomes minus a -3. And that becomes +3. Equals R squared. So 3 squared plus 7 squared equals R squared. 9 plus 49 equals R squared. R squared equals 58. If it wanted R, I'd square root it, but it doesn't ask for R, it asks for the equation, and in the equation R is squared, so I don't even have to do that last step. What I want to do is replace the H, the K, and the R squared. So X minus a -2 becomes +2 squared, plus Y minus a -3 becomes +3 squared, equals my R squared, which is 58. Good so far? All right, example 2 says put the equation into standard form, then find the center and the radius and graph the circle. So this is why we reviewed complete the square, because you have to complete the square. How many times do we have to complete the square? Twice, because there's 2 squared terms. So the first thing I'm going to do is group all the x's together, all the y's together, and I'm going to bump the constant to the other side this time. So I'm going to do x squared minus 6x. I'm going to leave the space because I'm going to fill it in. Plus y squared minus 2y. I'm going to leave that space because I'm going to fill it in. And I'm going to bump the 6 to the other side this time because that's where my constant goes in my standard form. The good news is they typically go easy on you with these. A circle has to start with the same term, so you're typically not taking out a term, and if you are, it's the same term, so you divide by it. So 6 divided by 2 is 3. 3 squared is 9. I'm going to add the 9 here. And this time, instead of subtracting the 9 from the same side, I want the constant to go to the other side. So I'm going to add it to both sides. If you're keeping it on the same side, you have to add and subtract. But if you're doing the same thing to both sides, you're doing the same thing to both sides. Yep. 6 divided by 2 is 3, and 3 squared is 9. We take b, we divide it by 2, and we square it. That's how you complete the square. Yeah.
You wouldn't have a negative in front of it?
No, because you always square it. So it always goes positive. When we factor it, we keep the negative. Yep. All right, now I go to the second one, the y's. Take the 2, divide it by 2. That's 1. Squared, it's 1. Add 1 in here and add 1 to the other side. And now we factor. So the square root of x squared is x. The square root of 9 is 3. Take the sign from the middle, which is negative. Put it in the parentheses and square it. God bless you. Do it again. Square root the y squared, it's y. Square root the 1, it's 1. Put the sign from the middle. Square, it's negative. Square it. And combine all these. So -6 plus 9 is 3 plus 1 is 4.
You don't have to square that.
You do not. Nope. What's the question asking for? Center and the radius. What's my center? 3, 1. What's the radius? 2. And it wants you to graph it. So obviously if I had a graph included, it would be more accurate. For now, I'm just going to kind of eyeball. So the center is at 3, 1. And my radius is up. Yep, sign of the middle. All right, Example 3, find the x and y intercepts. So on every single equation graph, blah, 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 whatever it is, how do we find the intercepts? So for the x-intercept, what am I going to make 0? Y equals 0. And for the y-intercept, x equals 0. So for the x-intercepts, my x is going to stay as x. My y becomes 0. This would stay x minus 4 squared plus negative 2 squared equals 16. X minus 4 squared plus 4 equals 16. X minus 4 squared would equal 12. And then I would go to square root both sides, and what do you got to remember to do? Plus and minus. So I square root, put the plus and minus in front of that 12, and I get x minus 4 equals plus and minus the square root of 12, which we're going to simplify. Good. That's a 4 and a 3. So this is plus and minus 2 root 3. And then I would add the 4. So x would equal 4 plus and minus 2 root 3. How do we write intercepts, though? Good. So it'd be 4 minus 2 root 3, comma 0, and 4 plus 2 root 3, comma 0. Those are your x-intercepts. And now I'm going to repeat the process for the y-intercepts. So this time I make x 0. 0 minus 4 squared plus y minus 2 squared equals 16. Negative 4 squared, 16. Subtract the 16. Square root, there's no such thing as plus or minus 0. It's just 0. Oh, my squares got, sorry. So then I'd get y equals 2. So 0, 2 is my y-intercept. Okay. Does it make sense that there could be 2 x-intercepts and 1 y-intercept? Sure, right? If I had graphed my circle, it would be positive 4, positive 2, and I would have gone down 2, right 2, left, 4, sorry, up and down. I would have gone all the way. And it's going to cross your x-axis twice, but it's only going to hit and touch your y-axis. There are times in which you could have neither. So like a neither scenario would happen when I go to square root. What's there's a negative number. If I go to square root a negative number, then I don't have that intercept. So if I had a circle that was just in the first quadrant, it's going to have neither. So when I go square root, it's going to be like the square root of negative 5. Well, there is no square root of negative 5. I would know that intercept does not exist. Okay. Questions on that one? Okay, so we're going to start for today. We're going to do parabolas tomorrow. If you want to start so you're not swamped tomorrow, then you can go through and do all the circle stuff of tonight. And then tomorrow you can do all the parabola stuff. If you want to punish tomorrow then wait. I don't care. It's up to you. Yeah. Yeah.